Howdy do. Let's get going on example 5 and 6, you guys. So this is a brand new relationship between segments intersecting outside the circle, which these two nifty segments are tangents and secants. Whoa, right? The more types of segments involved, the better, right? Guys, and since this involves tangent and secants intersecting outside the circle, I'm going to call this tangent secant. So this is the tangent secant property. Guys, so let's go back to that lovely Prezi to find out the relationship between secants and tangents intersecting outside of a circle. Alrighty, so basically what all this is saying is that the tangent segment squared, so if you square this piece right here, the tangent piece, it will equal, this is going to kind of follow like our secant rule. So that will equal the secant line, the outer segment of the secant line, so BC, times the length of the entire secant, which that's broken down into BC and AB. So tangent squared equals the outer segment times the outer segment plus the inner segment. So that side, or the secant part, is going to flow very similar to when we had the secant relationship back here, which I'm going to do this. Okay, so that's kind of flowing like this. So outer segment times outer piece plus inner piece. So the secant part is going to stay the same as this property. So keep that in mind. All right, you guys, let's get going. Okay, so on this one, we just have to find the value of x on example 5 and y on example 6. Okay, so let me go ahead and label my secant and tangent lines because that is always good to help us identify those pieces. So my tangent segment is PQ and my secant segment is SQ. All right, let's get going. So I'm going to start with the tangent piece. Okay, guys, so what our tangent piece is PQ. Okay, so we think back to that rule. We're going to square the tangent piece. So I'm going to have PQ squared equals, so now let's look at the secant, SQ, equals the piece of the secant that's outside the circle. Which piece of the segment is, or the secant is outside the circle? Yes, it is. It is RQ. You guys are math geniuses. Holy hot dog. Okay, so it's going to be RQ times the length of the whole secant, which are these two pieces added together. So that's going to be SR plus RQ. All right, let's start filling in some values, you guys. Bam, 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 and bam. All right, so PQ is X. This is going to be X squared equals RQ, which is 4, times RQ again, which is 4, plus S to the R, which is 5. All right, let's simplify this thing. Then we'll be done. So X squared is just X squared equals, okay, which you can distribute the 4 through, or you can simply add that together and multiply, which in this case, I think that's going to be easier to add and multiply. So it's going to be 4 times 5 plus 4, which 5 plus 4 will give me a 9. All right, let's keep going. So we got X squared equals 4 times 9, which is 36. All right, really close, you guys. How do we undo the square? We do square root that thing. That is the inverse of a square. And I'm going to square root that thing on both sides. So the square will cancel out the square root. Okay? And so I'm left with x equals the square root of 36, which is technically plus or minus 6, but x represents a segment length, and it does not make any sense to have a negative segment length. We cannot go back in time or like go under the circle or behind the circle. It just doesn't make sense in this situation. Okay, so I'm just going to leave it as a positive 6. And guess what, you guys? That was donezo, and that was short and sweet, so I'm going to draw a cute cat. There we go. Yay! It's a happy cat. All right, let's tackle example 6, you guys. Nice job.